Hello friends, welcome to Rajavali Education channel. In this video, we are going to see results of Faraday's experiments on electromagnetic induction. When the bar magnet is placed close to the coil, some of the magnetic field lines of the bar magnet passes through the coil. That is, the magnetic flux is linked with the coil. When the bar magnet and the coil approach each other, the magnetic flux linked with the coil increases. So, this increase in magnetic flux induces an EMF and hence a transient electric current, that is, temporary electric current, flows in the circuit in one direction. At the same time, when the bar magnet is taken away from the coil, the magnetic flux linked with the coil decreases. The decrease in magnetic flux again induces an EMF in an opposite direction and hence an electric current flows in the opposite direction. So, there is a deflection in the galvanometer when there is a relative motion between the coil and the magnet. In the second experiment, when primary circuit is closed, magnetic field lines are produced around the primary coil. When secondary coil is moved towards a primary coil, magnetic flux is increased in the secondary coil. So, an EMF is induced in this secondary coil. This induced EMF will produce transient electric current in the secondary coil so that galvanometer shows momentary deflection towards right side. At the same time, when the secondary coil is taken away from the primary coil, magnetic flux is decreased in the secondary coil. This decrease of magnetic flux will induce an EMF in the secondary coil. This induced EMF will produce induced current in one direction, that is opposite to the previous one. So, galvanometer shows left side deflection. In Faraday's third experiment, when primary circuit is closed, magnetic field lines are produced in the primary coil. Magnetic flux is increased in the secondary coil. So, an EMF is induced in the secondary coil. This induced EMF will produce a current in that coil. So, galvanometer shows momentary deflection towards right side. When the circuit is broken, magnetic field lines are disappeared in the primary coil. So, magnetic flux is decreased in the secondary coil. This decrease of magnetic flux will induce a EMF in the secondary coil in an opposite direction. So, this induced EMF will produce a current in the secondary coil in an opposite direction. So, galvanometer shows momentary deflection towards left side.